Artificial recharge is the means by which surface water from rivers or from dams is diverted and stored in the underground in an aquifer. And the reason that this is done is because it's a safe form of storage. To take water when it's available and when there's surplus surface water and transfer it underground and hold it in storage is a wise way of ensuring that you've got a secure water source for when you need it. And this is done either for storage on a seasonal basis, in other words, water being transferred in winter time if that's when the rainfall is, and underground, and then used again in summertime, or in a long-term basis for security against droughts, where it would be held in storage for years and then pumped out from the aquifers in times of drought.
And that will help in the future for water supply and to make water supply more sustainable. Places that are already using artificial recharge are places like Atlantis, that's doing it for the last 30 years. Calvinia, Karkams, Williston, places like Polokwane doing it for the last 20 years. We're also looking at Port Elizabeth, Sedgefield, as well as Plettenberg Bay. Outside South Africa, artificial recharge is used quite a lot. Places like Windhoek. A major part of the water supply is actually coming from artificial recharge. The Americans are quite keen on this, as well as the Australians. The Department of Water Affairs developed the artificial recharge strategy 3 years ago, and as part of that we are actually initiating pilot studies. And this current pilot project that we're doing in Prince Albert is a process that we initiated a few years ago, and we went into partnership with the local authority, Prince Albert Municipality.
Prince Albert gets its water from both groundwater and surface water. Most of the water, in the order of 80%, comes from borehole water, and the balance comes from river flow from the Swartberg Mountains.
This is the place where the stream comes down off the Swartberg and actually goes into the furrow, which a little bit further down goes into the pipeline, which then goes down to town and supplies the waterworks for the municipality, but also the whole furrow system throughout the town.
What we've noticed is that during the summertime the water levels in the boreholes in the aquifer drop substantially, and it drops over about in the order of 50 meters, and effectively by the end of the summer period the storage in the aquifers is largely depleted. Now if there are good rains after that in the winter time, then the aquifer will get replenished again and it will be ready for heavy use during summer. However, if the rains do not come substantially, or through climate change it becomes more variable and erratic, then the aquifers might not fill up and they won't have that volume for use in summertime.
During this last dry season, I think the dry season was about for the last 10 months, we had a lot of problems with our pumps, and we found out our aquifers or our bowls has run dry, so we couldn't supply the water that is needed every day in our constituency or in our community. We have about 3,000 cubic meters of water to deliver per day. So in order for us to supply all our users with water, we had to pump our pumps at a certain rate. So we had a massive expense on all our borehole pumps. We had to sort of refit them and fix them where they have broken, because we basically overpumped them.
But like most towns or many towns in South Africa, they have a surplus of water in winter time, but in summertime they're stressed for water, or they have water shortages.
At this stage we have a problem with our water storage capacity. Our factor is we can only supply half a day's worth of water. The Water Services Act tells us that we need to have at least two days of water available, and we're not complying at this stage.
So we started with a detailed study of the levels and the groundwater temperatures and the quality of the water and the quantity and what it was all being used for and where it was all going. And I think it quite quickly became apparent that there were periods in the year, particularly in the winter, when there was a lot of water that could be stored elsewhere. And for years people had been talking about building dams in various places, but there were always constraints and always problems with the dams.
Part of the problem with that was that this 5 megaliter reservoir would really mess up our entrance into our town. This is a small town. The greatest part of our income is through tourism. So we can't decide as to how we should do this. So, and this is going to be at extensive cost.
What we decided to do was look at the idea of transferring surface water when it's available underground and storing it underground and ensuring that prior to summer that the aquifer is actually full.
An underground reservoir would, save us a lot of money that we can use somewhere else where we desperately need to in order for us to deliver proper services and so forth.
Obviously we had to do a lot of fairly detailed research to see whether it was feasible here. And so for the last couple of years we've been very closely monitoring the groundwater levels and the abstraction rates and the quality of the water and various other things.
And now we're at the stage where we are doing a little bit longer test to see if it's actually going to work.
This year fortunately we had quite good rain and snow a week before the test. So not only did we sit with a position of an almost empty aquifer, but also a lot of very good quality water to put inside it. So the test was conducted under ideal conditions, I think.
Recently, the furrow between here and the waterworks was replaced with a pipe. Now, what we are doing is we are testing artificial recharge using this water. So we've got an off-take point on the pipeline, and we've put in this temporary pipeline that takes the water and then injects it into the borehole underground. So this rig that you've seen here is basically just for measuring the flow, the volume of water we're putting into the ground, and for taking water samples, and for extracting any air that might be in the pipeline out of the water so that we're not putting air underground, and for screening the water to get any leaves or anything in the water out so we don't put those things into the groundwater.
In Prince Albert, the concept of artificial recharge is very, very promising because the geology of this area lends itself to storing water underground. And what we see over here is that these rocks that are dipping down steeply underground, they form natural compartments, and there are a number of them. And in each compartment there are boreholes, and each compartment is separated from adjacent ones. So it's in effect what we have is a series of dams underground. So you can build up your storage until all the compartments are full one by one.
Storing water underground, water is not evaporating, and that is quite a huge benefit from the department side, and because we are promoting sustainable use as well as effective use, and we are supporting the conservation of water.
If this test work, we'll be the first to support this because then we can better our situation in town.
Preliminary results are extremely encouraging, that the water was going in, the aquifer was accepting the water at a rate that, at least at the rate that we were expecting, and possibly even more. So I'm extremely positive about the whole thing, because for the first time in the history of this town, instead of always abstracting water and taking water from the river and taking water from underground, the whole thing has turned around now, and people are actually have for the first time started to bank water for the summer. They're actually being more proactive and saving the water that's otherwise going to waste and is not being properly managed. It's now, the potential is there to do that, and it's a hugely important turning point for this town, that with a relatively simple infrastructure and inexpensive infrastructure, we can do a lot about ensuring the long-term water security for the town.
We believe it is working currently, and in future what we'll do is we went into a licensing process. On the municipality side, they need to do the design and the implementation on the bigger infrastructure.
Then this will all be put underground and be permanent infrastructure put in place.
It's a simple operation. It doesn't require a lot of running around and opening and closing of valves. It's a very simple infrastructure that just allows the water to be put back underground where it should be.
The department is looking for new initiatives on supplying water to towns. As a lot of people know, that the surface water resources in South Africa is becoming to the end. The building of new dams and pipelines is quite expensive, and groundwater is one of the resources that is going to be developed quite extensively in future.
And not only will it help in providing security of water, it will also be a huge cost saving in terms of the municipality not having to build concrete reservoirs for water storage.
So this aquifer and this underground dam will put us in a position where we can supply that the demand of our consumers.
And so that's what the whole concept is all about, is essentially using this natural subsurface storage to its capacity.